All numbers are floating point. You may remember that JavaScript has only one numerical data type, and that is the floating point data type. It's convenient because you don't have to think about the type of the numbers that you're working with, but there's a trade-off because decimal fractions are not exact. JavaScript provides the standard numerical operators: addition, subtraction, multiplication, division, and modulus. The number type also has a handy method toFixed, which returns the number fixed to n decimal places. Let's try some examples. So the first thing is we're going to take a look at the type of the integer value 1. We can see that the type of 1 is number. Next we'll have a look at the type of a decimal value, 3.14. And again we see the type is number. So that's just to demonstrate that there's just the one numerical type, and that is number, which is in fact a floating point data type. Addition works as expected. 1 plus 1, we get 2. Subtraction, same again. 10 minus 1 is 9. Multiplication, 3 fours are 12. Let's try some division. 22 divided by 7. Get a decimal number. And modulus, 22 mod 10, 2. I mentioned that decimal fractions are inexact when represented with the number data type. To demonstrate that, we'll take a look at 0.1 plus 0.2. Obviously we're expecting 0.3. But what we actually get is 0.3, then a whole lot of zeros, and then 4. This is where the toFixed method comes in very handy, because we can say 0.1 plus 0.2 to a fixed number of decimal places, and I just want to see the one decimal place, and that looks more like what I was expecting. The other alternative to avoid this problem of inexact decimal fractions is to work with whole numbers. This is commonly used when working with money. Instead of working with parts of dollars, instead we convert everything into cents. Instead of having $3.5, for example, to represent $3.50, we convert that into cents and work with 350 cents. So my same example repeated again, but this time I convert each of the decimal fractions to a whole number by multiplying by 10, perform the addition, and then at the end divide by 10 to get back to the correct value. And you can see when I do that, because I was working with whole numbers instead of decimal fractions, the result is correct.